Today we are going to discuss about the electromagnetic spectrum sources in medical physics. I am Dr. Karthika from the Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Before going into electromagnetic spectrum, we will discuss about the dispersion. First, this shows the refraction of light by a prism. First one, we are going to apply the white light and it passes through the prism. The refraction can be done. The final output is the colors, rainbow colors, Vibgya, violet, indigo, blue, green, yellow, orange and red. This effect is called dispersion. See this one. It happens because the white light is a mixture of all the colors in the rainbow. While coming into the wavelength and color, the white light is made up of different colors with wavelengths ranging from 0.004 millimeter violet to 0.007 red. Okay, here see this picture. Here the lasers, however, it only emits the light of a single color and wavelength. This type of light it is known as monochromatic light here. Okay, this shows the electromagnetic spectrum. It includes radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays and gamma rays. Okay, then what are the features of electromagnetic spectrum? Electromagnetic spectrum, it contains the waves like radio waves, microwaves, infrared, visible, UV, X-rays and gamma rays. Here, thus rays, it can travel through a space or vacuum. In a vacuum, they travel at a speed of 3 lakh kilometers per second. They are all the transverse waves with oscillations at right angles to the direction of the travel. And this electromagnetic waves have transfer energies also. See this one. Electromagnetic energies with transfer energy. Here the frequency is measured in hertz. See this one. Here the wavelengths decrease going along the electromagnetic spectrum from radio waves to gamma rays. And the next picture, it shows the frequencies increase going along the electromagnetic spectrum from radio waves to gamma rays. This diagram, it shows the different aspects of wavelength and frequencies for electromagnetic spectrum from radio waves to gamma rays. Okay, here the radio wave photons have the lowest frequency and the least energy, and the gamma ray photons have the highest frequency and the most energy. In this one, here the intensity and distance about the radiation, it also considers that whenever the radiation is absorbed by matter, the photons transfer their energy to the matter. Here the energy deposited by a beam of electrons, it depends upon the number of photons and energy of each photon. The intensity of radiation, it means how much energy arrives at each square meter of surface per second. And the final one is the intensity of a beam radiation decreases with the distance from the source. Here the beam gets spread out. Also the beam gets partially absorbed as it travels. Okay, some high energy electromagnetic radiation, ultraviolet, X-rays and gamma rays are known as ionizing radiation because they have enough energy to remove an electron from an atom or molecule. Okay, see this example. Here the photon hits an atom or molecule and removes an electron. Okay, if cells are exposed to ionizing radiation, they can damage the DNA in the nucleus of the cell. This can cause mutations and the cells divide constantly without control. This is called cancer. Here, very high dose of ionizing radiation can kill cells. Excessive exposure to UV radiation can lead to the sunburn or even skin cancer. If the exposure is increased, the damage will be more. Okay, here we have the difference of X-rays and microwaves. Here, X-rays are used by radiographers in hospitals to check for broken bones. X-rays pass easily through the flesh but are absorbed by denser materials like bone and metal. X-rays imaging also used in airports to check the contents of bags. Here, the microwaves are used to send signals between mobile phones and mobile phone host. Here, when you make calls on your mobile, your phone emits microwave radiation. Some of this is absorbed by your body and may cause heating of body tissues. The heating could result in medical conditions, possibly including cancer, but there is no conclusive evidence here. The precaution for X-rays, the radiographers should wear lead aprons, and they have to stand behind the concrete to protect themselves. While coming into microwaves, the precautions, it limits the amount of time you spend talking on a mobile phone. Okay. What are the applications of electromagnetic spectrum? Here, see this one. First one is radio waves. It is used for broadcasting, communications, satellite transmissions. And microwaves used for cooking, communications, and satellite transmissions. Infrared radiation is used for cooking, thermal imaging, short-range communications, optical fibers, TV, remote controls, and security systems. And thus visible light, it is used for vision photography illumination. Okay, ultraviolet radiation is used for security marketing, fluorescent lamps, detecting forged banknotes, and disinfecting water. Okay, X-rays used for observing the internal structure of objects, airport security scanners, and medical X-rays. And gamma rays used for sterilizing food and medical equipment and detection of cancer and its treatment. Thank you. Hope you all understand the electromagnetic spectrum and its applications in medical physics. Thank you. Thank you all.